So in this video we are going to do a process simulation on Aspen Plus. So this is our problem statement. So we have to produce a 50 kilomole per hour of ethylene benzene using SRK method. So we have to use the PFR reactor. So these are the conditions for the PFR reactor. These are the components. You can read this. So let me go to the Aspen Plus environment. So the first thing you have to give is the component. So benzene, toluene, okay, then ethylbenzene, then the last one is diethylbenzene. Okay, so this one is DEB, this one is BD, okay. Next is you have to give the method. So it is given, you have to use the SRK method. Click next, then run. Hopefully no error and warnings will come. So there is a warning. So free water method should be steam NBS. Okay, we can change this. Run again. Yeah, there is no error. Then we can go to the simulation environment. First, feed stream. So E for ethylene, B for benzene, then mixer, then you have to use the reactor, PFR reactor. So PFR, okay, then connect. So this is product, this is product 2. Okay, now let's see what are the conditions for the streams. So E and B streams. B contain 5% toluene, 25 degree and 20 bar pressure. Okay, so then click next. So 25 degree, 20 bar pressure. So this one is not given, flow rate is not given, so we have to take the some gassing value. Okay, so I'm taking 50 for the benzene. This is mole fraction, this is 0.95, 0.05. okay, click next. Next is 25, 20, 50, same. Flow rate is not given, so we have to give some gas value. So mole fraction is 1. So next is mixer, then next is reactor. So reactor is working at 20 bar pressure and 400 degrees Celsius. Okay, and 2 bar. Okay, so we have to specify the temperature. So this one is 1.6, sorry, this one is 1.6, this one is 8. So next, there is no reaction, so we have to give a reaction set. So reaction type is, we have to look for the reaction type. So reaction type is not given, so for that we can take power law model. That is a common type of reaction. So next So 1 1 1. So this one should be EB, ethylbenzene. Okay, so the next one is ethylbenzene plus ethylene, E. So DB. Okay, the next one is toluene plus 2E. Toluene plus 2E. So it is giving you ethylene plus propylene. Okay. So now we have to give the kinetic parameters. So these are in vapor phase. So this one for first reaction we have 22,500. Okay. We have to take care of the units, these are very important. Next one is DEB. So this one is 22,500. kilocalorie per kilomole. Third one is 3.8. Okay. So click next for the next step. Aspen Plus will automatically take you to the next step. Then you can see there is a pressure. So pressure is 20 bar, pressure drop is 2. So now you can run the simulation. So results are available. So for that you can check the results. Okay, so we are getting some results, so this is good. So toluene is consumed, like fully consumed, because of the high residence time in the reactor. So the next thing is we have to flash it at 142 degrees Celsius. So let's flash it at 142 degrees Celsius. So there is no pressure drop around the flash. Okay, so you can write it 0, then run the simulation again. Okay, then you can check whether this flash is working properly or not. So there is no component in the vapor phase. So that is because in the question it is saying the product from the reactor is flashed at 142 degrees Celsius. So vapor is recycled back, so we have to recycle the vapor, then we can see whether there is a product in the vapor phase or not. So let's do the next step first. So you have to separate the propylene from the stream. Okay, separate the propylene. So this is Okay, no, this is separate. This one is so okay, remain. So you can write so the split fraction of the propylene is 1, so all of the propylene is going to the this prop stream. So then you can run it. So you can see that warning. So warning is, so there is 0 feed to the block. Okay, it is because there is no feed in the vapor phase, so it bypasses this. Correct. Okay, so let's continue, because when we join the recycle, then it can work properly. So let's do the next step. So then it is heated up to 90 degrees Celsius and then compressed to 120 bar. Okay, so let's heat it. So heater, then it should be compressed. Okay, so your heater is working at 190 degrees Celsius and there is no pressure drop or change against this. Then this is isentropic. So I am taking some arbitrary isentropic efficiency. You can change it. So let's see if it is working. Still it is not working. So there is the warnings because there is nothing in the vapor phase, but still we will continue and then we will see whether it will work or not, because when I read the question, there is a benzene recycle, so benzene will be recycled back to the reactor. So let's see if that will create any effect. Okay, so now next is we have to put a distillation column at it as it is given in the question. We can use DSTW and we have to get a purity of 98% for the ethylene. No, it should be EB, ethylene, ethylbenzene, and then it should be minimum of 97% for the DEB. So let's connect. So your upper product is distillate product is benzene. Okay, so benzene is getting recycled. Benzene, correct. So we can write it as bottom. So what is given? So for DC1 your reflex ratio should be between 1 to 10. Okay, your light component is B or E and then heavy is EB. Condenser is total condenser, working at pressure is 20 bar pressure. Okay, so we can write 20 bar pressure. Reflux ratio should be between 1 to 10, so I'm taking 10. But so light component is benzene, so the heavy component is EB, correct, 0.0001. so check it. Yes, everything is correct. Now let's okay, so we have to recycle back the benzene. So now there is an error. So error is at mixer. Okay, I can tell you the error in the mixer is because of the flow rate of this benzene and ethylene stream. So we have to guess a value, or we have to check from the literature that people have taken which flow rates. Okay, for that I have already checked it from the literature. So you can take the flow rate of the benzene as 70. Okay, and for this ethylene you can take flow rate as 80. So now it should work, then we will see if it is okay. Now results are available, see, so everything is working. So the main problem is in the question, flow rate of the benzene and flow rate of this ethylene is not mentioned. So that is our part to find out. So for that you have to either go to the literature, or you can use the hit and trial method. So you can give some random number and then start simulating, but that can take a very large amount of time, or if you are lucky, then you can like guess the flow rates in 1 or 2 iterations. So the next part is you have to add a second distillation column. Okay, so reflux is 50, pressure is 20. Okay, so the light component is ethylbenzene and the heavy component is diethylbenzene, correct. So now again we have to put a distillation column. So this is your distillation column. So your light component is ethylbenzene, correct, let me check. Yes, and your heavy component is DEB. So reflux ratio is 50. Then this is 20, this is 20. Let's see if our simulation is working or not. So results are available, as you can see. Now let's check the results. So before that, what the question is asking, so minimum purity of EB and DEB is giving, it should be 98% and 97%. Okay, then let's check it. Okay, mole fraction. Okay, so for EB it is 99.7% and for DEB it is 99.062%. okay, now I think we have achieved our goal. So these are more than 97 and 98%, so I think this will work. Then let's check the result for the PFR. So your PFR is working at 400 degrees Celsius. This is fixed, okay, as per the question. So your residence time is second, so 48 second. So it is very not very quick, but it is there. So your okay, this amount of duty we require to operate this reactor, and this is the balance. You can also check the amount of so minimum reflux ratio is 2.28, your actual reflux ratio is 50, so your feed stage is 21. okay, so the actual number of stages are 40. It is given distillate temperature, bottom temperature, everything you can find out what different parameters we get from this simulation. okay, for this distillation column. So then next one is this distillation column. So let's see the results for this distillation column. okay, your feed so it is saying you have to give the more stages. okay, so the number of stages are 27. okay, and your feed stage is 14. yeah, correct. So reflux ratio is 10. You can change the reflux ratio, then you can see what are the effects of the reflux ratio on this process. So this is how you do the process simulation of ethylbenzene formation in the Aspen Plus. Hope you like this video. If you like this video, kindly subscribe, comment. If you want to know anything about Aspen Plus, then I can give you I can give you the insight of the Aspen Plus. Then if you have any doubt for this particular simulation, then you can approach me on this Gmail. I will put my Gmail in the description box. You can get my Gmail from there. Hopefully you like my video. okay, if you have any suggestions, then you can give me some suggestion. If you want to ask questions, then you can ask me also. Thank you very much. Take care.